So my name is Jasper Potts. I work for Oracle. I'm one of the architects on IoT, working on some new IoT products. And I used to work on JavaFX and Java client and have been involved in the Java group for many years now. So I don't know how many of you saw the keynote demo this morning with the car. So the idea here is to go through, I want to show you the sort of concepts and how you actually practically do what we did with the car. So IoT is one of those buzzwords that everybody's talking about at the moment and in the industry. So in terms of the basic concepts of what does IoT mean, so on the left we have a set of sensors and actuators. So here you would have things like lights or temperature sensors or motors. So these are things you can get data from and set data to. So this is how you connect the real world to the digital world. But they're very low level. So we then connect those up to a gateway device, and that bridges between those small low level devices and the cloud and the internet. So that's our devices to the or things to the internet, so Internet of Things. So here we have those connected up to our IoT cloud. So this is our big data center off somewhere in the cloud that's going to be taking all the data from these sensors and doing interesting things with it. And then we have things like our classic sort of business intelligence application that's going to be trying to make sense of that data and do something useful with it. So what I have to show you here today is a very simplified version of this so that we can explain it in the time we have. So we have all of the hardware pieces involved in a real system, but in a very small scale. So I have two parts of the system here. I have a original Raspberry Pi with some sensors and actuators, and then we have a second Raspberry Pi with a touchscreen that's our UI that lets us control things. And then they talk over Wi-Fi. So first of all, let's look at the hardware, or what are all the pieces that I have on the table here that we're going to show you. So the first thing is for the UI, we have a Raspberry Pi 2. These came out about a month ago. I wish they were available when we built the car demo that we showed you in the keynote. They're a really powerful little cheap device. I'm really impressed by their performance. And it's amazing what you can get for the price. And then connected to that, I have a 10-inch or 9-inch touchscreen that allows you to then interact with that. So on the other side, for the actual sensor device, I have a earlier simple Raspberry Pi Model B+. I then have a I2C Blink M, which is a colored LED that can change color controlled by digital signals over the I2C bus. I have a temperature sensor that's going to be measuring our ambient temperature and sending me that data over I2C. I have a analog to digital converter and a joystick. So the joystick gives us analog movement signals as I move my fingers, and then the analog to digital converter converts that into a digital signal we can read. And all of those pieces are assembled on a prototype board. So this is the end result when I assemble all of those pieces and solder them together. So this is my Raspberry Pi with the board on the top and the little boards soldered together on top of that. So this allows you to very quickly put together simple little test systems with various sensors and try things out. So going on from that, the next thing we want to look at is how do we describe those pieces of information? So we have the position of the joystick, the color of the LED, and the temperature sensor. So how are we going to describe those in our source code? So here I'm using properties. These are part of the JavaFX APIs that are part of Java 8. So the first thing we have is a double property, and here, so we have position X and position Y of the joystick. We then have temperature. We have display units for whether we're going to display that temperature in Celsius, like most of the world, or Fahrenheit, like the US. And then we have the color that represents the color of our LED. So I then have a final guy. So my initial temperature, my raw data is always in Celsius, and I then have a display temperature, which is that same temperature converted into Celsius or Fahrenheit. So the example here was to show how we can create a property whose result is bound to a computation. So it's always up to date with the current value of the temperature property converted into the appropriate display unit. So the last thing is something I created for this demo, and we also used in the automotive demo for the keynote. And this is a cool little class that replicates these properties over a network. So I can create as many instances of this demo model on different devices, and anytime I change a property, all the other devices will get that property change immediately. So this makes it very easy for us to propagate around. So this is something that's solved by many different IoT systems out there. This was a simple solution I used for this demo. In cars, we have CAN buses, which is the classic example. For the cloud services, there's MQTT and many other networking technologies that allow you to make things talk to each other. But the end result is we have a property that represents something on one device and the same property on the other device, and we want to keep the two of those in sync. So what happens here is when I move the joystick, it's going to send an analog voltage to the analog to digital converter. It's going to convert that into an I2C signal that's going to be picked up by our Java code, which is going to then update the property. That property gets replicated over the network, and the property on the other side is then bound to our user interface and is going to change a dial. The technology I'm using for the networking here is something called JGroups. It's a Java library that's been around at least a decade, and it makes it very easy to connect multiple Java virtual machines over the same subnet. It's used by JBoss, Java EE server, for doing all of their clustering. And so it's a reliable technology that's easy to use for connecting multiple devices together. So next I want to look at I2C, and how do we actually connect all of these sensors up to our Java code. So in case you're not familiar with I2C, the simple way of thinking about this is I2C is just like USB. So all of us will be used to having our desktop computers or laptops and plugging in a keyboard or a mouse or a camera or anything over USB that you just plug it in and it works. I2C is very similar, but on the circuit board level. So it's like a smaller version of USB. You can connect up to 256 devices to the same bus, and they can all talk together. I'm using a library for Java called Py4j, which is an open source community library. There's also an officially supported Java library called DIO, which Angela was talking about in the last session here, if you were in that. So there's two alternative libraries. This one's only designed to work on the Raspberry Pi and makes it very easy to connect up to these sort of devices. So here I'm looking at how do we wire together the physical connections. So One of the nice things of I2C is there's only 4 wires involved. So you have your ground and your plus 3.3 volts for powering the device. And then you have a data connection and a clock connection. And you can connect as many devices as you like onto those same 4 wires. And they each have a unique address that you can talk to them with, so they can all share the same bus. So here we're going to look at what the code is involved to actually talk to one of those I2C devices. So the first thing we have to do is get an I2C bus object. There's 2 I2C buses on a Raspberry Pi. The main one, number 1, is what most people will use, and it's available on the main connector. There's also a second one that's used by the camera accessory, but generally you don't need to worry about that. So here it's nearly always 1. The second thing is we're going to get a Java object that represents the actual device on that bus. So as I said, you can have multiple devices connected. And so in this case, it's going to be our temperature sensor. And the 48 in hex is the address of that device on the bus. And usually most devices have some way you can set that address so that you can have more than one of the same device. Then we're going to do the same for our analog to digital converter. I have an extra class here that I've created that wraps the analog digital converter and does a bit more of the logic for how to talk to that. But we'll go into those in more details. And so this one's on 49, so it's on a different address on the same bus. And then the last thing I have here is the LED. That's on address 9. So here I have 3 I2C devices on the same bus that we can talk to. The final thing I'm going to do here is send a small piece of initial code to configure the LED and turn it off. The default state when you first plug power into the device is that the LED flashes different colors, and so I just want to turn it off when I first run my program. So this is sending a simple message to that device of the character 0 followed by the number 0. And that just says set it off. So the next thing we're going to look at is I want to, on a regular basis, query the temperature and other information from these sensors. And so here I'm going to use a JavaFX timeline. So you may sort of wonder why I'm using UI classes here when I'm running it on a device with no screen or UI attached. They have just some simple built-in primitives for things like run this piece of code every so often. And also we have all the properties there. So there's some nice base classes there that are really nice to use whether you're doing UI or not doing UI. So here I have a JavaFX timeline. So every 0.2 of a second, it's going to run through and do a series of jobs. So it's going to read our temperature sensor, check the position of the joystick, and then update the color of the LED. And that's just going to run indefinitely for the length of the running program. So I'm going to next dive into a bit more detail about how do you actually read the temperature sensor. So these little sensors are really low level. So they're talking in bytes and bits and really low level sort of constructs. So what I'm going to do is read 2 bytes from the temperature sensor. Now, I2C only supports bytes, but sometimes you want to have a number bigger than a byte. So in this case, it contains an integer that's 2 bytes joined together. So we need to read those 2 bytes and then join those 2 bytes by shifting 1 to the left. So there's a little bit of code involved in talking to these low-level devices where you have to understand how bits are represented and do a little bit of moving of bits and bytes around to convert it from whatever the raw type is on the chip into either a integer or a long or a double or some type that Java can understand and is comfortable with. So there I now have my temperature value as an integer. Now that integer value has no meaning. I can't tell you what that is in Celsius or Fahrenheit, if it's hot or if it's cold. It's just the raw value that the sensor gives me. So in the instructions for the sensor, they give you this calculation to convert that arbitrary number into a temperature in Celsius. So here we multiply it by this factor, and that gives us the final number in Celsius. And once I have that, I can then set my property in my data model to that new value. So each time, so every 0.2 of a second, I can go through, read those 2 bytes, convert it into a Celsius value, and set it into that property. So reading the joystick is very similar. I have a bunch of code which I sort of printed up. So there's a bit more code involved in this than the temperature sensor, but not a lot. I sort of showed you there just to give you an idea of how much code. And basically, most of it is the initial setup of the device. So the analog to digital converter is quite flexible. It can have many different modes. So you need to have a bunch of code that tells it how you want it to behave and what type of data you would like it to collect. So most of this code is involved in setting it up, and then it does the similar thing to the temperature sensor, that it reads the value and converts it into a nice Java double value. So here I just read the value between 0 and 1 of the position X and 0 and 1 of the position Y, and set those in my 2 properties. And then the final one is, how do I go the other way? So the first 2 have been reading things, and this time we're going to write to the I2C bus and send out information to the real world. And so here I want to take the color value that's in my color property and set that to the color of the LED. Now the LED is interesting that it uses a slightly different I2C. Rather than reading or writing bytes to known addresses, you send messages. So it accepts simple little messages where the first piece of information is a character that tells you what command. This is very much like a function call or a method call. So here we're going to send it C for setting the color, and then I'm going to send it 3 bytes for the red, blue, and green. And then the final thing is telling it how many bytes I've sent. So that's how we set the color on the LED. So the next bit I'm going to show you is how to build the user interface that we've got here. So how can we show you that, easily build a UI to show you those values? So we have a tool for JavaFX called Scene Builder, and this is a graphical tool that lets you draw UI controls. So what we have here is one of the dials. So as I move my little joystick, it's going to move the needle on the dial. So this is very simply constructed. We have an arc object, which is the background, the little dots, and it's just drawn as a dashed line. I have a needle, which is going to move around, and I have a central text to show me what the value is. A nice trick that our UI designer who worked on Scene Builder who taught me was, if you want to really easily have a needle on a dial, if you create a rectangle the whole width of the dial, I can then just go to its properties. And find the rotation. So all JavaFX nodes have base transforms like rotation. So because this object, the needle goes all the way across, but some of it is transparent, when I rotate that, it now rotates around the center. So all I have to do is set my value to be the rotation value, and that will automatically rotate my needle around. I don't have to do any trigonometry or calculations or other mathematics. So it makes it very easy to build. So once I took my dial and I created a few other controls here. So one that says switch for Celsius or Fahrenheit, a bar that shows me my temperature, and a color picker on the right. And each of those are separate files like the one we just looked at for the dial. And I embed each of those files as FXML imports into one master file, which is my application. So the whole UI for my application is just drawn in the tool. So if we go back to the slides. So let's look at the actual code. So that's what my UI is going to look like. So this shows you all the files involved. So my main class, my JavaFX main class or application class, that's going to load up my main app FXML. It has a Java controller class for its logic and a CSS file which gives it the theme and all the styling. And then it's going to include several other files, so one of which is the gauge file, which also has its own CSS file and controller for the logic. So this gives you a nice structured way to build applications. So this is the code for the gauge FXML. And this is something, I haven't made it big here because this is something that the tool generates that you shouldn't have to hand edit. The key things I wanted to pick out here was, if I show you back to the tool, so if I go through each of these pieces, there's a code tab, and I can give them a name. So the FX ID for the needle is called needle. And so each of the pieces that I want to be able to change the state when the application is running, I need to give a name, so in my controller class, I can talk to them. So here I have needle, the title label, and the gauge label. Those are the three items inside that UI file that I want to be able to talk to. So this is my controller class. So it has a timeline that just goes through, and so the reason why there's a timeline here is if you get a very abrupt value change from like 0 to 100, then it looks really weird if the needle just jumps. Your eye catches that. So what happens here is every time I get an update of the value, I animate between the old value and the new value. So it looks a lot more realistic, like a real physical hard gauge. Because obviously, there's no way a real gauge, the needle can just jump magically from one place to another. And then I have a method for setting the title, so we can choose what the title is at the bottom of the gauge. And this is one of the nice things here is you can create reusable components this way. So this gauge I'm going to use twice, once for the X and once for the Y, and it's a single piece of code. There's a single controller class and a single FXML file. So I then have my app FXML, and what this does is it's basically a container that has embedded all of those other components like the two gauges. And again, I give each one of those components a name so I can talk to them in my code. So I have X gauge, Y gauge, the temperature switch, the temperature, and the color box. So in my controller class for my whole application, this is where I can now connect all of those little components and their controller classes up to my data model that we already talked about. So here, all I have to do is bind the properties of those various different guys up to my model. So if we look at one particular line here, we have data model LED color is bound in a bidirectional thing to the color box controller's model. So this is really nice. FX provides a bunch of binding that allows you to connect the UI components up to our data model, and anytime one of them changes, that change gets reflected in the other. And so we don't have to write any code to connect that up. So then the final piece to make my whole application is the main class, and all this is doing is constructing my controller and passing it in the data model. So the top level app controller, it needs one piece of information, which is our central data model, which is going to be replicated over the network. So I use the fxml loader to load that fxml file and said, when you get to constructing the controller, pass into the constructor the demo model. So that's the only sort of clever thing we're doing here. And the final thing we have is when the application is stopped and exited, we tell the demo model to stop talking over the network and exit cleanly. So that's our entire UI application. So next, let me show you the whole thing put together. So it's a little bit blurry, unfortunately, but yeah. So here on the desk here, I have the touch screen that we were talking about, and I have a Raspberry Pi 2 connected up to it, and then I have a second Raspberry Pi, which has all of the electronics on we were talking about. So this is the physical device, and these two Pis are talking via Wi-Fi to each other. So they have a little tiny dongle in them that gives them Wi-Fi access. And so as I move around the dial, you can see that pretty much instantaneously the two dials should move. One of them is a little bit sticky, the x-axis. It's not going to quite work through. It didn't quite like traveling through so many suitcases around the world, unfortunately. But the Y for us is pretty much accurate. Unfortunately, there's a small delay between the camera, so it's actually much faster in real life and much smoother. You see a slight blurriness and jumping of the needle. On the physical device, it's absolutely smooth when it works. Unfortunately, I can't project. And then going the other way, on the right, I have the color thing. So as I touch on the color, we can see if we go up to green, pink. Oh yeah, that's been a little bit slow. So yeah, if I touch down in the bottom left corner for pink, the LED goes pink. If I touch over in blue, it should catch up, yeah. So it takes a little while for it to catch up. So it changes to color. So I can just sort of touch in the corners or any color and mix and match colors. I also have my little temperature sensor. If I touch on my little temperature sensor, it goes up. Unfortunately, it's already, we can see it actually goes off the top of my gauge there, so I have a little bug, because it's already pretty hot here. I wasn't quite expecting it to be that warm. And if I click on Fahrenheit, it's going to change that our value between Celsius and Fahrenheit. So we have a little touch interface. And then one more thing I had to show you. So I thought this was cool, but just to make it a little bit more fun, we have my iPad running exactly the same FX app. So I can have exactly the same FX app with the same code running on an iPad and controlling the same thing over Wi-Fi and LinkedIn. So I thought that was really cool when you can have the same switches and drag around. And so it's exactly the same UI running on the iPad. So the final thing really I have for you is where you can find out more information on all these pieces. So that's me at the top if you want to follow me on Twitter. I can't guarantee there'll be anything interesting. That's the blog that I have with a couple of colleagues on JavaFX, where we post lots of interesting stuff and news updates on everything in the JavaFX world. There's also Oracle IoT to find out more about how do you take the same sort of ideas and concepts and apply them to big corporate and enterprise solutions. And then JavaFX Ports is the cool technology I tried out last week that lets you run your same JavaFX app onto your iPad or Android device. and then the Raspberry Pi for all of the fun little devices.